Database engine is processing ERP data in the cloud. Data flow within the organization and across the globe. Input data. Designed engine for data processing from input data. Output. Printout. Data migration, Excel, text, XML, and JSON. Management graphs. From OLAP Cube. A database engine processing ERP, Enterprise Resource Planning, data in the cloud refers to the use of a cloud-based database management system, DBMS, to store, manage, and process data related to a company's ERP software. ERP software is used to manage business processes such as accounting, inventory, human resources, and customer relationship management, CRM. In a cloud-based ERP deployment, the ERP software and related data are stored in the cloud, and users access the system through a web browser or mobile application. The database engine is responsible for managing the storage and retrieval of data within the ERP system, and the cloud infrastructure provides the necessary computing resources to ensure efficient and reliable processing of the data. Some of the benefits of using a cloud-based database engine for processing ERP data include scalability. The cloud provides virtually unlimited computing resources, allowing the database engine to scale up or down as needed to accommodate changing data processing demands. Reliability. Cloud-based databases typically offer high levels of availability and reliability, with built-in redundancy and failover mechanisms to ensure uninterrupted access to data. Security. Cloud-based databases can be configured with robust security measures to protect sensitive ERP data, including encryption, firewalls, and access controls. Cost-effectiveness. Cloud-based databases can be more cost-effective than on-premises solutions, as they eliminate the need for upfront hardware and software investments and reduce ongoing maintenance and management costs. Overall, a database engine processing ERP data in the cloud can provide companies with a flexible, scalable, and cost-effective solution for managing their critical business data. The security of a database engine in a cloud architecture depends on several factors, including the design of the database engine, the security measures implemented by the cloud provider, and the security practices of the users. Here are some measures that can be taken to ensure the security of a database engine in a cloud architecture. Access control. Access to the database engine should be strictly controlled, and only authorized personnel should be granted access to the database. Encryption. All data in transit and at rest should be encrypted to protect it from unauthorized access. Backup and disaster recovery. The database engine should have a robust backup and disaster recovery plan in place to ensure the integrity and availability of data in the event of a system failure or disaster. Network security. The cloud provider should have strong network security measures in place, including firewalls, intrusion detection and prevention systems, and security monitoring. Authentication and authorization. The database engine should have a strong authentication and authorization mechanism to ensure that only authorized users can access the data. Vulnerability management. Regular vulnerability assessments and patch management should be performed to mitigate potential security risks. Logging and monitoring. The database engine should have a robust logging and monitoring system in place to track all database activity and detect any suspicious behavior. In summary, the security of a database engine in a cloud architecture requires a comprehensive approach that includes access control, encryption, backup and disaster recovery, network security, authentication and authorization, vulnerability management, and logging and monitoring. It is also essential to stay up to date with the latest security best practices and to implement a robust security policy to protect sensitive data. Vulnerability assessment and penetration testing, pen testing, are two security testing techniques used to identify and mitigate security risks in software applications, networks, and systems. While both techniques are used to identify vulnerabilities, there are some differences between them. Vulnerability assessment. A vulnerability assessment is a systematic review of a system or network to identify potential security vulnerabilities. The process involves using automated tools to scan the system for known vulnerabilities, misconfigurations, and weak points. The results of the assessment are used to create a report that details the identified vulnerabilities and provides recommendations for remediation. Penetration testing. Penetration testing is a more advanced technique that involves simulating an attack on a system or network to identify vulnerabilities that might not be detected by a vulnerability assessment. The process involves manually attempting to exploit identified vulnerabilities to determine their impact on the system or network. The results of the testing are used to create a report that details the vulnerabilities identified and provides recommendations for remediation. While vulnerability assessment and penetration testing are different techniques, they are often used together to provide a comprehensive assessment of a system's security posture. Vulnerability assessments are often conducted prior to penetration testing to identify potential vulnerabilities and prioritize testing efforts. Penetration testing is then used to validate the vulnerabilities and determine the impact of a successful attack. In summary, vulnerability assessment and penetration testing are two important security testing techniques used to identify and mitigate security risks. While vulnerability assessments use automated tools to identify potential vulnerabilities, penetration testing involves simulating an attack to identify vulnerabilities that may be missed by automated tools. Both techniques are essential to maintaining the security of systems and networks. Server security is the practice of ensuring the confidentiality, integrity, and availability of data and resources stored on a server. The following are some measures that can be taken to ensure server security. Access control. Access to servers should be strictly controlled, and only authorized personnel should be granted access. Access control can be enforced through the use of passwords, two-factor authentication, and RBAC policies. Encryption. All data stored on the server should be encrypted to protect it from unauthorized access. Encryption can be implemented at various levels, including the storage level and the transport level. Backup and disaster recovery. The server should have a robust backup and disaster recovery plan in place to ensure the integrity and availability of data in the event of a system failure or disaster. Network security. The server should be protected by a firewall, intrusion detection and prevention systems, and other network security measures to prevent unauthorized access and mitigate potential security risks. Patch management. Regular patching should be performed to address known security vulnerabilities and mitigate potential security risks. Vulnerability management. Regular vulnerability assessments and penetration testing should be performed to identify and remediate security vulnerabilities. Monitoring and logging. The server should have a robust monitoring and logging system in place to track all activity and detect any suspicious behavior. Physical security. Physical security measures should be in place to protect the server from physical threats such as theft or tampering. In summary, server security requires a comprehensive approach that includes access control, encryption, backup and disaster recovery, network security, patch management, vulnerability management, monitoring and logging, and physical security. It is also important to stay up to date with the latest security best practices and to implement a robust security policy to protect sensitive data and resources. Server load balancing is the process of distributing incoming network traffic across multiple servers to optimize resource utilization, maximize throughput, and improve availability and scalability. Load balancing ensures that no single server is overloaded with traffic, which can cause slowdowns, outages, and other performance issues. There are different load balancing techniques and technologies, including round-robin DNS. This technique distributes traffic across a set of servers by rotating the IP addresses returned by DNS queries. Layer 4 load balancing. This technique distributes traffic based on network transport layer information, such as the source and destination IP addresses and ports. Layer 7 load balancing. This technique distributes traffic based on application layer information, such as HTTP headers, cookies, and session information. Hardware load balancers. These are specialized devices that are designed to handle large amounts of traffic and perform load balancing at high speeds. Software load balancers. These are software applications that run on standard server hardware and perform load balancing using a variety of techniques. Load balancing can be performed using a variety of algorithms, including round-robin, least connections, IP hash, and weighted round-robin. These algorithms determine how traffic is distributed across servers based on factors such as server capacity, current load, and connection quality. Load balancing has several benefits, including improved performance and availability. load balancing ensures that incoming traffic is distributed evenly across multiple servers, preventing any single server from becoming overloaded and improving overall performance and availability. Scalability, load balancing allows organizations to scale their infrastructure to handle increased traffic and demand. Redundancy, load balancing provides redundancy by distributing traffic across multiple servers, ensuring that if one server fails, traffic can be automatically redirected to another server. Security, load balancing can help prevent distributed denial of service, DDoS, attacks by distributing traffic across multiple servers and blocking suspicious traffic. In summary, server load balancing is an important technique for optimizing resource utilization, improving performance and availability, and ensuring scalability and redundancy. Load balancing can be performed using a variety of techniques and algorithms, and can be implemented using specialized hardware or software applications. Designing a robust database engine for business applications in the cloud requires careful consideration of several factors, including scalability, availability, security, and performance. The following are some best practices for designing a robust database engine for business applications in the cloud. Data modeling. A well-designed data model is essential for ensuring scalability and performance. The data model should be optimized for the application's needs, and data should be structured in a way that facilitates efficient queries and data access. Database architecture. The database architecture should be designed with scalability and availability in mind. This may involve using distributed databases, sharding, or other techniques to ensure that the database can scale to meet increasing demand and can survive failures without impacting availability. Replication and backups. Replication and backups are essential for ensuring data availability and disaster recovery. The database should be configured to automatically replicate data across multiple nodes to ensure redundancy, and regular backups should be performed to protect against data loss. Security. The database should be secured against unauthorized access and attacks. This may involve implementing access controls, encrypting data at rest and in transit, and monitoring for suspicious activity. Performance optimization. The database should be optimized for performance to ensure that queries are executed quickly and efficiently. This may involve using indexing, caching, or other techniques to reduce query times and improve response times. Monitoring and alerting. A robust monitoring and alerting system should be in place to detect and respond to issues as they arise. This may involve monitoring database performance, availability, and security, and alerting administrators when issues are detected. Disaster recovery planning. A comprehensive disaster recovery plan should be in place to ensure that the database can be quickly restored in the event of a disaster. This may involve using automated failover systems, regularly testing backups, and ensuring that backup data is stored securely. In summary, designing a robust database engine for business applications in the cloud requires careful consideration of scalability, availability, security, performance, and disaster recovery. By following best practices and implementing appropriate technologies and processes, organizations can ensure that their databases are able to meet the demands of their applications and provide a reliable foundation for business operations. The best user interface, UI, design is one that is intuitive, user-friendly, visually appealing, and efficient. Here are some best practices for creating a great user interface design. Consistency. Consistency is key to creating a user-friendly interface. Use consistent color schemes, typography, and layout throughout the interface to create a cohesive look and feel. Simplicity. A simple and minimalistic interface design helps users focus on the most important features and tasks. Avoid clutter and unnecessary elements that can distract from the main purpose of the interface. Visual hierarchy. The visual hierarchy of an interface should guide the user's attention to the most important elements and actions. Use contrast, size, and placement to create a clear visual hierarchy. Usability. The interface should be designed with usability in mind. The user should be able to easily and efficiently navigate the interface and complete tasks without confusion. Feedback. Providing feedback to the user is important to ensure that they understand the outcome of their actions. Feedback can be provided through visual cues, animations, or sound effects. Accessibility. The interface should be accessible to all users, including those with disabilities. Use clear and concise language, provide keyboard navigation, and ensure that the interface is compatible with assistive technologies. Responsiveness, the interface should be responsive and adapt to different screen sizes and devices. Use responsive design techniques to ensure that the interface looks and functions well on desktops, tablets, and mobile devices. Testing the interface with real users is important to ensure that it is effective and user-friendly. Conduct user testing and gather feedback to identify areas for improvement. In summary, a great user interface design is one that is consistent, simple, visually appealing, usable, provides feedback, accessible, responsive, and tested with real users. By following these best practices, designers can create interfaces that are intuitive, engaging, and efficient, resulting in a positive user experience. We are using the following methodology for system design. DFD stands for Data Flow Diagram, which is a graphical representation of how data flows within a system. It is a visual tool that helps to represent the processes, data stores, data flows, and external entities of a system, and how they are interconnected. DFDs are commonly used in software development, system analysis, and business process modeling. There are several elements in a DFD. 1. Process. A process is a task or activity that transforms data. It is represented by a circle or rectangle with a label that describes the process. 2. Data flow. A data flow is the movement of data from one process to another or from a process to a data store. It is represented by an arrow with a label that describes the data. 3. Data store. A data store is a repository where data is stored. It is represented by a rectangle with a label that describes the data store. 4. External entity. An external entity is a source or destination of data outside the system being analyzed. It is represented by a rectangle with a label that describes the external entity. There are different types of DFDs, including context diagrams, level 0 DFDs, and decomposed DFDs. A context diagram is the highest level DFD, which shows the scope of the system and its external entities. A level 0 DFD is a more detailed diagram that shows the processes and data flows within the system. Decomposed DFDs are lower level diagrams that provide further detail about specific processes or data flows. DFDs are useful in many ways, including 1. Understanding the flow of data within a system. 2. Identifying areas for improvement or optimization. 3. Identifying potential sources of errors or inefficiencies. 4. Communicating complex information in a simple and intuitive way. Overall, DFDs are a useful tool for understanding, analyzing, and improving systems by representing the flow of data in a visual and intuitive way. Thank you.